Hello.
Hey, McKinley. So are you sticking it to your brother since he has to go to school and you don't?
No.
No. Missing a prime opportunity. I figured out what I meant the other day. For math class, he's going to Mrs. Newburn's class, not Miss Kittle's.
Yeah, I think he said something about that. About Newburn, and then he joined one of your Zoom calls?
Yeah, he goes every day.
Oh, okay.
I think he uses her computer. Something like that. Where is the rest of the class?
I'm guessing they're all still sleeping.
Nah, it's a pretty good sleep to 150. How'd that homework go last night?
It wasn't that hard.
Good. Any questions on it?
I had nothing on it.
Okay. Well, I will call out the answers. Let's see, what, 1 through 14 all? Okay. So let's see, number 1 was 60 centimeters squared. Number 2, 32.8 centimeters squared. Number 3, 5 centimeters, not squared this time because we're calculating height. Number 4, 15 meters. Number 5, 24 square units. Number 6, 2 root 3 square units. Number 7, 2x squared minus 6x square units. Number 8, 4k squared plus 7k minus 2 square units. Number 9, there's 2 answers here. The area is 36 square centimeters and the perimeter is 26 square centimeters. Number 10, the height is 10 centimeters and the area is 400 square centimeters. Number 11, the height is 5 centimeters and the area is 80 square centimeters. Number 12, area is x squared plus 5x square units, and the perimeter is 4x plus 10. Number 13, the area is a squared minus 9 square units, and the perimeter is 4a units. And 14, the height is k plus 3, and the area is k squared plus 10k plus 21 square units.
Yeah, I thought the question was asking for the other sides of the triangle, not the area and perimeter.
Yeah, that was what capital letter A was. B was base, H was height, and P was perimeter.
Oh, to me, they look like another base in height.
All right, number 17 is 130 square units. Number 18 is 56 square units. Number 27 is 144 square meters. And number 29, 2 parts. Part A is 768 square feet, and part B is 3 cans. And that was it. For you guys that aren't live here, just make sure you're turning that in. I am putting the things in the grade book. Yesterday was the first grade of the quarter. Here's your homework for tonight. We get 3 formulas, 3 new, well, one is actually a new formula. The other 2 you've already had, 7th and 8th grade. But we're going to prove them today. Just like yesterday, we proved area of a rectangle, base times height. We're going to prove 2 of the formulas. Well, we'll prove all 3, but 2 of the ones you've already used before. We just never proved them. And since McKinley, you're the only one here, you're going to have to tell me if I'm going too fast.
Okay.
All right. Here we go. So the 3 shapes today are parallelograms. We've done those before. Triangles, we've done those before. We have never done area of a rhombus, like a one specific formula. We basically said that a rhombus is a parallelogram, so we use the same formula as parallelogram. We get a different formula for a rhombus today. All right. So here we go. Well, we've got to prove all of these. We're going to start with the parallelogram. And if you remember from Amen. If you remember from 8th grade, the way that we proved it was we basically took some scissors, we cut off one side of it, we took that triangle, we pasted it on the other side, and we said, look, magic, rectangle, base times height. And while we weren't lying to you, I mean, the formula is base times height, but that's not really a proof. That's just kind of cutting things around and saying, please believe me. Now, let me prove it to you for real. All right, so I need to prove that parallelogram PQRS is the area of it is base times height. So let me do that. The first thing I'm going to do is I'm going to do literally the same thing I did in 7th and 8th grade, which is make a triangle. Except this time I'm not going to cut it off and place it on the other side. I'm going to make another triangle exactly the same way, right? I'm just making a second triangle there. Now the first triangle is inside that parallelogram. The second one is outside. But if you look, and I'll go ahead and kind of guide you through the proof here. If I look at this shape right here, I've actually made what shape?
Rectangle.
Yeah. So keep that in mind. All right. So here's the proof. So once that's done, that's just construction. I can immediately say that PV is congruent to QT because, well, it's a parallelogram. And remember, a parallelogram, that means opposite sides are parallel. That means they never change their relationship to each other. Therefore, any perpendicular that I drop down will be equal to any other perpendicular. Any perpendicular I drop down will be equal to any other one. Well, I already dropped 2 down. Therefore, those two, the ones in red, those have to be congruent. And the reason, or the reason I'll quote for that is, well, that's a definition of parallel lines. Lines that never touch, never intersect, and always stay the same distance away from each other. Okay, so what I'm really doing here is I'm going to show you that the 2 triangles that I just made are congruent to each other. Well, PS is congruent to QR because it's a parallel. The black part is a parallelogram. Opposite sides are congruent. Right? That's either, I wouldn't say I should say property of a parallelogram, not definition of a parallelogram. So I can immediately claim that, Ben, that those 2 triangles are congruent because I showed that this side is congruent to this side, and this side is congruent to this side. Why are those 2 triangles congruent?
Well, because of the SSA postulate.
The who?
SSA, side-side angle.
Except we don't call it that. We call it
whatever you call it. 2 sides, 1 angle theorem.
We call it the hypotenuse leg, right? And that is the ASS, but we just don't call it the ASS.
Didn't he say SSA, not ASS?
Yeah, but remember that would be the same thing. Just because he said the order's backwards, ASS is the same as SSA, right? But we don't have that, by definition. We call it hypotenuse leg. Maybe it's because we don't want to spell bad words. I don't know. But it is easier to say hypotenuse leg than it is to write 3 letters.
But
okay. So I've just shown that those 2 triangles are congruent. I guess this is where the 7th and 8th grade proof comes from. The fact that now if I cut one off, it's the same as the other one, and you do make a rectangle. But let's finish this proof in a more rigorous manner. So I'm going to talk about now the black part, the parallelogram. So what I'm saying right here is that that parallelogram is equal to, well, I'm going to choose some parts here. I'm going to choose this part right here, P, Q, R, V. So, well, we don't know it's a trapezoid, but it is a trapezoid. We don't know the formula for area of a trapezoid, so that's why I'm not going to say trapezoid. But that piece right there, that's this piece, plus this triangle right here. So that's all the pieces, parts, maybe call this area 1 and this area 2. Those are the pieces, parts that make up the parallelogram. And that's that postulate from yesterday, postulate 19, that says the area of a big part is made up of the non-overlapping parts that make up the shape. All right, well, that's cool. And by the way, if you look at the bottom of the proof now, I got area of PQRS and I have area of PQRS. So we're halfway there. I just need to turn this part into BH. All right, how am I going to do that? All right, so my next statement, what I'm going to say is another way of saying this shape. So I'm going to say, let's see, P, Q, T, V, and McKinley told me that shape is a
Triangle.
In blue is a triangle.
Yes, it's a gigantic triangle. It just doesn't have a third side. So it's more like a rectangle. But
Yeah, let's call it a rectangle. So that rectangle is equal to, let's see, what am I claiming? I'm claiming that rectangle is made up of, hey, that same trapezoidal part, PQRV, plus that triangle right there. So notice what I've set up here from these two statements. Let's see. They both now say something about some shape. One's a rectangle, one's not a rectangle, one's parallelogram. But they both have a PQRV and they both have these two statements. And notice that these two statements, the ones I just circled, well, those are part of two triangles. And those two triangles are congruent. And we had that one theorem from yesterday that said that if two shapes are congruent, then their areas are the same. So I'm just going to do some substitution here. The first thing I'm going to do is I'm going to, once again, got to sneeze. Excuse me. Once again, I'm going to, well, one of these shapes, I'll show you here in red. One of these shapes, PQTV, PQTV, I didn't underline it. PQTV is a rectangle. And we know from yesterday the rectangle is base times height. So notice now this says exactly what that says. The problem is that this PQTV, I kind of want it to say PQRS. All right. So let's see, how can I make that say PQRS? So I'm going to go back to the previous statements. You see here in blue what I've circled? I've circled two triangles that are congruent. Therefore, their areas are congruent. Therefore, what I circled right here are exactly the same. Oh, I got to give you a reason for that's just the area of a rectangle. All right, so back to our substitution here. So PQRS is equal to, let me just erase all my drawings right here and then I'll show you. All right, that's better. So how do I get my last statement, the one right here, from these four statements right here? So here's how it comes from. Well, here's my PQRS, right? And I got a BH. So somehow this right here turns into BH. Well, I got a BH right here. And that says that that's equal to PQTV. So it's a triple substitution. I go back to this statement, which is PQTV, which says it's equal to PQRV plus QTR. But wait a minute. PVS and QTR are exactly the same. So I can substitute those two. Therefore, through a triple substitution, I get to make that last statement. All I'm doing is taking these 1, 2, 3, 4 statements and just doing a whole bunch of substitution. Okay. By the way, you may have gotten lost in what I did right there. Basically, I showed you we started off with a parallelogram and we figured out that the area is equal to base times height. And all of that is why we don't do that in 7th and 8th grade. All right, so put this in your book of truth. This is theorem 11.2, 11.2. And 11.2 basically says you got a parallelogram, it's base times height. Well, that's a pretty convenient formula. Not too hard to understand or to use, base times height. You've done this many times in 7th and 8th grade. We okay to move on? McKinley?
I think so.
All right. Two quick notes. Remember, the base is any side of the parallelogram. It doesn't have to be the bottom. It can be, but it can be the left side or the right side or the top. But as soon as you determine what the base is, the height is that perpendicular distance between the base and the opposite side. And I generally draw a separate picture of a parallelogram. So here's a parallelogram. And if I choose this side to be the base, then the perpendicular distance for the height would be right here. So a right angle right there. So just remember, any side, that's the worst parallelogram ever drawn in a math class. All right. I'm embarrassed. Okay. Moving on. So in, let's see, in 8th grade, it was pretty easy. I gave you this. Men, what's the area? Ben is getting a cookie.
It is 15 minus 5.
Sorry, my mute wasn't working because I had to shut off every other application because this is the last thing I have to do till I'm done with school. Thank goodness. So when I tried pressing spacebar, and I'm like, why is this thing not unmuting? It's because I wasn't
On a
actually
different program.
selected.
Yeah.
I wasn't on the Zoom application.
All right.
Anyways,
What's the area?
well, it's 10 feet,
10 square feet, right?
10 square
So
feet.
in eighth grade, you did that, and we called it a day right there. Well, you're basically in the second year of math in high school, even though this is your first year in high school. So it won't be as easy as that. So tonight it's going to involve Pythagorean theorem and some special right triangles. So let's just review special right triangles before we do one. Remember, those come in two flavors, the 45, 45, 90. And the 30, 60, 90. So let's see, do we remember this? Remember on a 45, 45, 90, the two legs are called A, and the hypotenuse is called A root 2. On a 30, 60, 90, the side opposite the smallest angle, that's 30, is called A. The other leg is called A root 3, and the hypotenuse is called double A or 2A, okay? I will help you out for today. I'll write these on the board so that they're in front of you. But you got to remember these for tonight. So hopefully you have these in your book of truth still, or you can find them. You will need them. All right, so let's see where we're at. We are calculating the area of a parallelogram. So McKinley, what's the formula for area of a parallelogram?
Base times height.
Seems pretty simple, right? So what's the base here?
Well, the base is 10.
What's the height?
The height is h.
The height is h. We have a problem because it's not there. Ben, you got any ideas?
Well, yeah, I do have some ideas. Because we know that this is this is the special right triangle.
It is a special right triangle. So 45, 45, 90.
Yeah.
So there's your special right triangle.
So that means that this we just gotta take 8 square root
equal to
8. A equals, wait.
What's the only bit of information we know on the triangle?
That the hypotenuse is A root 2.
Is A root 2. And we are told on our triangle that the hypotenuse is
8.
So set that equal to A root 2 and solve for A. Because remember, A on this one, it's hard to see because my triangles are backwards, but A corresponds with H. Can you flip that around in your head?
Yes.
Now, if it helps, instead of writing A, write
H.
There you go. Just for this one particular problem. Okay, so that setup would therefore would be 8 would equal to H root 2 and then solve. So what do we do to both sides?
Well, first we would multiply both. No, not multiply. Square. Gosh, I'm blanking.
What's attached to H?
Squaring.
No, what is attached to H?
A square root. So we have to use exponents.
Well, here's
the
issue.
Power of.
I understand why you want to square both sides, because you're going to think that if I square both sides, that I'll get rid of that square root. That's true, but we cause a problem. When you square that,
we'll have H.
We'll have H squared.
All right, that's a good point.
Times 2.
Well, I saw a little birdie the other day, and the birdie told me that maybe I should divide, both sides.
Divide both sides by the square root of 2.
Till you get the H, yeah.
All right, now we got to think back to the chapter we did on square roots. Were we allowed in our final answer to leave the square root in the denominator?
You are not allowed to have that as your denominator.
So what are we going to do?
We have to, now we use the exponent. Wait, no, because that still just gets H root 2.
How about
we just flip them?
How about we just multiply top and bottom? We're making the equivalent fraction by the square root of 2. That was how we got rid of it. So it's called rationalizing the denominator. We simply multiply the top and bottom by the thing on the bottom that's giving us problems. thing on the bottom that's giving us problem is the square root of 2. Because remember, what I'm really doing here is this whole thing, if I were to cancel, right? If I were to cancel, that whole thing is just a big fat number 1, right? So square root of 2 divided by square root of 2 is 1. Any number multiplied by 1 doesn't change. We're just choosing to write it as the square root of 2 over the square root of 2 because it gets rid of that square root in the bottom. So the square root of 2 times the square root of 2 is, Ben?
I'm thinking. Well, okay, so it's h equals 8 root 2 over 2.
Okay.
I was thinking about the step after this. This step, yeah. So, I mean, we can simplify it.
We'll simplify it.
Yeah, so it'd be h equals 4 root 2.
And now we take that and we do what with it?
We put that with h.
Keep talking.
And then that means h equals 4 root 2.
Keep talking.
Which means that since h equals 4 root 2, that must mean that the other side equals 4 root 2. Therefore, 4 root 2 minus 10.
Oh, you're overthinking this.
Yeah.
Remember, the formula was base times height for the parallelogram. We already knew the base was 10. We didn't know the height. Well, in blue there, you just figured out right here, you just figured out that h is equal to 4 root 2.
Oh, wait, I just saw us calculate the area. Oh, okay. So I'm sorry. The area is 40 root 2 centimeters or units squared.
That's right.
On the homework, for some reason, it didn't write like anything. So like there was nothing to square because they didn't have units.
You're right. Some of these will not have units. Okay.
Woo.
All right. McKinley, did you follow all that logic?
Yes, except for the bird, because Ben didn't tell me what bird it was.
Basically, Mr. C accidentally
clicking
He
ahead.
flashed to the second thing, so I knew what to do.
Ah, okay.
All right, so this is difficult because we're not doing 8th grade, we're doing high school work, and real world problems are not easy. So that's why these are a bit more challenging. All right, so there was parallelograms. It's just base times height. Now we'll do triangles. Remember I said 3 shapes. All right, you've been using area of a triangle for a while, 1/2 base times height, but it was never really proven to you, right? We're gonna prove it now. So here's my setup. I got a triangle. Triangle XZY, and I'm going to show that the area of that triangle is equal to 1/2 the base, which I'm going to choose YZ to be my base, times the height. All right. As we did before, I'm basically going to make a new construction. I'm going to make it into a shape that I already know the formula for. So here's what I'm going to do. I'm going to make a line that is parallel through X that is parallel to YZ. We just did that literally last chapter. I'm going to make another line that goes through point Z that is parallel to YX. And the definition of a parallelogram, oh, by the way, that's construction. The definition of a parallelogram is a 4-sided shape where opposite sides are parallel. Well, I just did that. So therefore, XWZY is a parallelogram by its definition. All right. And the reason why I made a parallelogram is because I know the formula for area of a parallelogram. So we can say some things. I'm going to basically now show that those 2 triangles, the red one and the black one, the big black one, are congruent to each other. So let's see. We know that since it's a parallelogram now, that opposite sides are congruent. So XW, YZ are congruent. XY and WZ are also congruent. And we also know that opposite angles of a parallel are congruent. So therefore, Y is congruent to W. Well, if we do some markings there, this one's you, McKinley. Let's see, that's congruent to this. This is congruent to this, and this angle is congruent to this angle. Why are those 2 triangles congruent, McKinley? McKinley?
I think he went to go get a cookie.
I think so too. Ben, why are those 2 triangles congruent?
Well, we know that those 2 triangles are congruent because of, well, for starters, they both share segment XY, so that's one thing.
Well, I've already marked everything on the board, so just read the board.
Okay. SSS. Because
Where do you see the third? Oh, I see. Okay, you are correct. Now that's not what I marked, but I'll buy your thing. Yeah, SS.
it could also. He did get a cookie.
McKinley,
It looks like a smiley face if you squint real hard.
you need to bring cookies for all of us next time. All right.
He's probably got a box of Chips Ahoy right next to him.
Ben, I didn't see the SSS, but you're correct. I chose SAS.
It could be SAS as well. Yeah.
Very good. All right. Okay. So what? I showed that the two triangles are grouped. Well, here's what I'm going to use that in the proof. So the next statement is I'm going to talk about the entire thing. So if you look at the entire thing, let's see, that says X, W, Z, Y. Well, we set it up to be a parallelogram. And by that one theorem that said that the area of the larger shape can be calculated by adding up the areas of all the non-overlapping parts, then therefore by postulate 19, that parallelogram is equal to those two triangles added up together, which is convenient. Why? Because we just said in the previous step that the two triangles are congruent. So suspiciously, I could have chosen either this one. Oh, darn you. I've done it so many times today. I could have either chosen that triangle or this triangle. Suspiciously, I chose this one. Why? Because that's the one in black, not red. And so basically, if I double that, since the two triangles are congruent, well, then it's equal to the area of that parallelogram. And it's starting to look more like my final answer. Postulate 18 says that if two polygons are congruent, then their areas are congruent. Okay. So let's see what I got here. Well, I got a problem here because mine says area of a parallelogram. It says area of a triangle. So somehow I gotta change from parallelogram to triangle. How am I gonna do that? Well, here's how I'm gonna do that. Well, because I know let me get rid of the drawings here. Because I know that the area of a parallelogram, that's this part right here, is equal to base times height. So that's what I'm saying right there. Area of a parallelogram is the base. I'm going to say YZ is the base and H is the height of the black triangle, right? And that's why I chose that one. And then on this side, I didn't change anything. I just repeated that. Okay. So what allows me to say that is because the area of a parallelogram, the previous theorem we just did, base times height. All right. Well, here's the cool thing is I just literally just move from, let me erase what I got here. All I'm doing now is moving this. I'm moving this to the left side right here. And I'm dividing and the right to the, and this side to here. And then I'm dividing both sides by 2. And when I do that, let me clear up the mess I just made. And when I do that, so left to right, right to left, and then when I do that and divide by 2, I get the final formula. So just a little bit of division, okay? And QED, we just showed that the area of a triangle is equal to 1/2 base times height. So write this one down. This is your second one. Many people prefer that as the formula to use, base times height divided by 2. Either one works. They're the same formula.
So if I was to bring cookies, how would you guys eat them? Since I'm on the other side of the world right now.
Bring them on
3D printing.
3D printing.
Yeah, from my knowledge, the only thing 3D printers uses are plastic or metal.
So that could change in the future. I mean, an upgrade, they could print pizzas.
Oh, yes, you're right. I have seen that. I have seen a machine that prints pizza. There might be a business model for you, McKinley. Come up with the first 3D printed cookies.
I mean, I think that would get me rich, but I don't know where to start at. I guess I fill it with cookie dough and then
and another arm with sprinkles or something, or flavorings of some sort. All right, we good with the triangle? 1/2 base times height.
Yeah.
Base
Yeah.
times height divided by 2. Okay. So once again, you're not in eighth grade anymore. You're in high school. So the proofs of the examples they give you will be much harder. All right. So here we go. McKinley, what kind of triangle is that?
Isosceles.
Okay. Ben, do you remember? Formula for area of a triangle is base times height divided by 2. If I call the bottom the base, guess what my problem is? Can I use this formula? What's my problem?
Well, there is a problem.
What's the
You
problem?
have the base, but you don't have a height.
I don't have a height, so that's my problem. But I certainly can throw 6 in for the base. Don't always assume that the bottom is the base, but I'm going to say, let's make the bottom the base here. All right, McKinley, you got any ideas? Well, that would be the height then. Any ideas?
Well, you could forget about it and go watch a movie, but I don't
Yeah,
see
not
that as
an
an
option.
option. So you turn the triangle into 2 halves.
Okay,
Might start, so it's instead of 6, it would be split into 2 3s.
okay. What allows you to do that?
Isosceles triangle
That's
has
the key point right there, is you could not do this with anything but an isosceles or equilateral triangle. So, I mean, think about this. I'll draw a really crummy triangle right here that's scaling. So here's a scaling triangle. And if we drop the altitude or the height straight down like this, notice I clearly don't break the bottom up into half. What allows me to break this one up into half is the fact that it is an isosceles triangle. And so therefore, yes, when you drop from the 2 congruent sides, these 2 right here, and you drop that altitude straight down, it does break the bottom or the 3rd side into half. And we have a theorem for that as well too. I can't recall the number, but it basically says that, remember, if you are anywhere on the perpendicular bisector of a segment, then you are equidistant to the 2 endpoints. So in other words, that's why these 2 are congruent. Okay, don't remember the number of that theorem, but that was a theorem. Cool. All right, great. Now we know that's 3. How does that make us any closer to finding the height?
well, I think we have to use tangents.
We can only use that if we know some angle measurements, and we only know 90. That doesn't give us.
Oh, okay, I forgot.
But that's a good idea. Maybe that could have gotten us there. We want this red dotted line. How are we going to calculate that?
Need to do something with 8 and 3.
Agreed. Guess what we're going to do, Ben, with 8 and 3?
Put them into the area thing.
Nope.
No, all right.
How
Wait,
about
no, Pythagorean theorem. The
Pythagorean
theorem.
theorem? There you go. So we can solve for that. It's a right triangle. We know the hypotenuse. We know one of the legs. We can solve for the other one. So all we're going to do is throw it in the Pythagorean theorem. Remember, 8 would be the hypotenuse, so it would be the C. All right, so we just do a little bit of Pythagorean theorem. We solve it. We get square root of 55. What do we do with that?
Well, you get just you could use your calculator, or
Nope.
you could take the square root of 5 and 5.
Nope.
No? Oh, okay.
5 times 5 is 25, not 55.
Oh.
How about we just take that and throw it into the formula?
Okay.
Doesn't it not say that h is equal to the square root of 55?
Yeah.
So throw that into the formula.
So it's just 6 times 50, square root 55
Over
2.
reduce.
Then you would get. You would get a 3 root 55.
And that would be in square units. Very good. All right.
I did
So
it.
definitely more challenging today. Let's do another one. Ben, what's the problem with this one?
Well, the problem with that one is, well, it's an equilateral triangle.
What do you know about equilateral triangles?
What just fell? Oh, that fell. Okay. So that means all sides and all the angles equal each other.
So how much is one of the angles therefore?
60.
We can. So we can immediately assume that this side right here, this angle is 60, this angle is 60, and the top one is 60. So if I drop a altitude straight down, right?
It'll cut
Well,
it in.
it's still isosceles in the sense of these two sides. So we get 3, but the problem is, well, there is no problem, right?
Well,
There are
it's the
two
same
ways of doing it.
before.
What?
Same way as before.
Same way as before, or
We could cheat and look it up on the internet.
no. Why did I write a 60 right here?
Wait, it's the 60. It's 30, 60, 90.
90, right. So we could use that fact, and I will say it will actually make our lives a little bit easier. Notice where the 6 is. The 6 is on the hypotenuse, right? So if the 6 is on the hypotenuse, it's saying that 6 is equal to 2a, therefore a is equal to? Go ahead.
I don't know why I'm drawing a blank.
Well,
It's
this is equal to this.
then A is 3,
A is
meaning
3.
that H is 3√3.
And then we can throw that really quickly into our formula.
And then
You can
yeah.
also use Pythagorean theorem. We would still get the same answer. 9 times 3 is 27. The square root of 9 is 3. We still get 3. Either way works, right? I'm not going to say that tonight for homework you can use either one on every single example, but here's one where you could. So take 3√3, throw it into H, and what do you get?
It would be
A number.
What would it be?
that.
What would it be reduced?
Reduced, it would be 18. Wait, yeah, 18√3. Take that divided by 2. Then we get 9√3.
And that's the answer in square units. Okay.
Of course.
So, like I said, these are not going to be as easy as they were in 8th grade, but they're also not impossible. I tried to go through every single example for special right triangles and Pythagorean theorem. We got one thing left, 10 minutes to go. One thing left, the rhombus. Now, here is a brand new formula that we're about to prove. You've never seen this before. Turns out that the area of a rhombus, if you can determine the two diagonals inside a rhombus, now I gotta be careful. McKinley, you paying attention?
I'm all ears.
All right. D1 is the length from A to C. Can you see that?
Yes.
It's not halfway, right? D2 is the length from D to B. So it's the length of the two diagonals, right? And what we're about to prove is that if you take these two diagonals, the distances of them, multiply them together and divide by 2, it's the area of the rhombus. Okay, so that's a brand new formula. You've never seen that before. All right, so let's do this sucker. All right, so we got a rhombus with diagonals D1 and D2. We're going to try to prove that if you multiply the two diagonals together, divide by 2, you get the area of the parallelogram, or area of the rhombus. And rhombus is a parallelogram, by the way. All right, the first thing I'm going to do is immediately claim that this triangle ADC is congruent to this triangle ABC. Why can I immediately claim that these two triangles are congruent, McKinley?
Because they are isosceles.
Maybe.
Oh.
Turns out they are.
Because because of our last proof. No, the proof before that with the.
How do we prove that two triangles are congruent?
But you could do ASS, all the.
All right, well, let's see what we got here. It's a
rhombus. SSS. It's a SSS.
It is SSS. Why? Because opposite sides of a parallelogram are congruent, but it's a rhombus. All 4 sides are exactly the same. And then lastly, reflexive property, this side of those two triangles. Oh, I got a mess going on there. The third side is congruent to itself. Therefore, let me clean that up. Therefore, the two triangles congruent. It's SSS. Okay, great. I've got triangle congruent to triangle. I'm going to use the same trick I did on the other two proofs. I'm going to start talking about some pieces, parts that I can understand. The first thing I'm going to talk about is the area of the triangle. Now, which triangle am I talking about? We're talking about this one, ADC. Now, remember I said that D1 goes all the way across. And if I call that the base, remember the formula for area of a triangle is equal to 1/2 base times height. Okay, so my B is going to be D1. I already got the half right here. That half comes from this half right here. So 1/2 times D1. Well, here's the issue. And the issue is that the height would be this distance right here. D2 goes all the way across. You may not remember this, but it turns out that for a rhombus, that the diagonals bisect each other. So I don't want all of D2. I only want half of the second. So the height, this part right here, I want half of D2. Can you follow that logic?
Yes.
Okay, so that's area right there. And what gives me the ability to say that? Well, two things. One, that I know the area of a triangle formula, and 5(3) is the one that says that the diagonals bisect each other. Okay, cool. Ben, 1/2 times 1/2. Is Ben getting cookies now?
No, I'm thinking. I'm here.
1/2 times 1/2.
1/2 times 1/2 is 1/4.
Agreed. So a little bit of multiplication going on there. All right. Well, let's see. It's starting to look more like this, but well, here's the problem. Let's see. I got to wind up with a rhombus, and I got a triangle, and I got a 1/4, and I got to turn it into a half. Let's see. What else can I do here? Well, I can say something about the rhombus itself. So A, B, C, D, the whole rhombus is equal to those two triangles, the one that we talked about before, added together, right? Well, and we're going to go back to the previous thing that we said about what happens when you say that two things are congruent. That means their areas are congruent. So that means that this area and this area are congruent to each other. I'm going to pick one. It doesn't matter which one you pick. I will pick this one. So if I double that, let me catch up. If I double that, that will equal this one. Now, what allows me to do that? That's just postulate 18, okay? Postulate 18 says if two things are congruent, then their areas must be congruent. I guess you could put some substitution in there as well, too. All right, so how do I turn this? Well, let me do this in red here. Well, this looks like, why are you not drawing? There we go. So this looks like this. That's good. Well, the 2 needs to turn into a half. I can do that easily by probably using some division or something. But I got area of a triangle, and this says D1, D2. That's a problem. And how am I going to get around that? Well, I'm going to go back to a previous statement that I said before. And the previous statement that I said before, this will be the substitution, says that triangle ADC is equal to this right here. This right here. And look what it says right there. It says area of ADC. So for what I just underlined in red, I can write that right there. So I'd have 2 times 1/4 D1, D2. And what's 2 times 1/4? Two times 1/4?
2 times 1/4 is just, well, you think about it, really, 2 times 1/4 is just a half.
And we're done. All right. So what did I just prove? I proved this. I proved that if you have a rhombus, that if you take the two diagonals and you multiply them together and then take half, you have its area. Here's a more calculator friendly one. D1 times D2 divided by 2. Now, you've never seen that formula before, but that will be for the area of a rhombus. And that's our third and final formula.
So that means I can go watch Transformers now? Or...
One last thing, and then we'll wrap it up.
Okay.
I do want to remind you that a rhombus is also what other shape?
A square,
Or a,
rectangle,
or
or a
a,
polygon, a
no, or a, I mean, it is a polygon. but-
parallelogram.
Right. And so I still want you to remember this is a second, it's not in your book, but I want to make sure you remember this. Just because it's a rhombus doesn't mean you only can find its area by doing d1 times d2 divided by 2. If you can find its base and its height, you can also just multiply base times height because it's a parallelogram as well too. So base times height will get you the answer as well too. But maybe they give you the diagonal. Tonight for homework, they're going to give you the diagonals. But always remember that you can, calculate the area of any parallelogram by doing base times height. All right, Ben, pick a number between 1 and 5.
7.
Pick a number
that's
between
an
1 and
option.
5.
3.
We will do 3 practice problems.
Oh.
All right, 3 practice problems. Pick
I
one,
got this.
McKinley.
I feel like doing 8 because
All right, let's do number 8. What's the shape?
it's a rhombus.
It is a rhombus. You can tell that because look, the sides are all the same, so it is a rhombus. We know from the thing that the area of, I'll put a little r for rhombus, is equal to d1 times d2 divided by 2. Do we know the 2 diagonals?
We know one of the diagonals.
So it turns out that if we know one of them, can we find the other ones?
Yes.
All right, well, let's do that.
Well, so first diagonal is 8,
Okay.
but the second one would have to be something else.
All right, so we got 8 times something unknown over 2.
Oh, I can make a triangle
Okay.
with that left side
Four.
4 and 5.
5, and we know this is a right angle. Therefore, we can use Pythagorean theorem to find this other piece and then double it. Yes?
Yes,
All
so
right,
the
so
answer
scratch
would,
over here.
so
so-
5 squared equals
Is
4.
the 5 A, B, or C?
It's a C.
All right, so I'm going to cheat and just start writing. 25 is equal to
Oh, a 16.
plus, we'll just call it A squared. All right.
Yeah.
Subtract
But-
16 from both sides.
You get a number that is
9
9.
is equal to A squared. Therefore, A is equal to?
3.
So that side is 3. So this side is 3. Therefore, my other diagonal is
6.
8 times 6
That is the 48.
divided by 2.
24.
Boom, done.
Yes. I
All
did
right,
it.
1 down, 2 to go. Ben, pick one.
Well, first you'd
Pick one.
how about we do number 10?
Number 10 isn't an option.
Fine, number 5.
All right, let's do number 5. What's the shape?
All right, it's a parallelogram.
And we know base times height. So I got a base of a 6. I don't have the height. So if I drop the height down, what do you immediately notice? What kind of triangle?
30, 60, 90.
So 30, 60, 90. So
Means it's
A root 3,
and then 2a. Right. So we automatically know that if the answer is 3, because we have 3, so 3 divided by 2 is 1.5. So that means a is 1.5.
Okay. So
so we have
area is equal to base times height, and we know the base is 6, and you just told me the height is.
the height is 1.5 root 3.
Okay, so 1.5, not 1.5 root 3. So let's see, that would give us what? 30 carrier 0 carrier 3. 6 times 1 is 6 plus 3 is 9. I'm getting 9 root 3.
Yeah, that's what I'm getting to. Yeah.
All right. Kinley, pick the last one. We're done.
Let's go with 9.
Number 9.
So the triangle is base times height divided by 2, and the base is 5.
So he wants to choose 5 as the base. This is the right angle. Okay.
Right.
So that means the height is
12.
okay. Therefore,
Oh, okay. This one was easier than I thought it would be.
Way easier.
60. 30. Yeah.
there you go. Now, did anyone notice it's a Pythagorean triple? 5, 12, 13. I
No.
know it's a right angle. Notice they left off the right angle right here. All right. Okay, that was it. Any questions?
I have none.
All right.
Ben?
Good luck with your homework. You can send me a chat if you need any help. I have my computer on until about 8 o'clock at night. So if you need any help on the homework, I'll send you a message. All right. I will see you guys tomorrow. Have a wonderful day. Don't eat too many cookies, McKinley.
Yeah, McKinley.
What? I only ate 3.